Yeah, hello everyone. Uh, so we'll begin with this webinar. So the topic of this webinar is multimodal retrieval using CLIP and LlamaIndex. So CLIP is a contrastive learning in image pre-training based model by OpenAI, which is publicly available. And LlamaIndex is a framework similar to LangChain for developing AI-based and LLM-based solutions. So we'll go over this topic and how we can build a product like for multimodal retrieval. So yeah, so how this OpenAI's Clip model works. I'll go over a few topic related insights first, and then we can maybe move on to the code further. Yeah. So CLIP is a pre-training based model which uses NLP, natural language supervision, zero-shot learning, transfer learning, and multimodal learning. So how it does this is with the help of image and text pairs. So we have a data set which is a combination of image and text citations for the image as well. So zero data learning and like as in with zero shot learning and leveraging natural language space with the vision transformers. So this work has been previously been used, and this is quite a benchmark for this model. So this data set used for this model, like initially was CIFAR 10 data set, like and now we are like this model currently is trained over ImageNet and MNIST data sets as well, so which are currently huge data sets. And we'll go over the how it is pre-trained. Uh, so deep learning models basically have been maybe trained over like more supervision and more data. So it is costly to train, and the ImageNet
Can
data
you
set
hear
for
me? You can
yeah,
hide, yeah, you can hide the
yeah,
bar below where it
uh,
says hide and
okay,
stop sharing. Just click on hide.
yeah, that. Uh, Let
Yeah,
me know
this
if
is correct.
yeah,
Yeah,
okay.
looks good now. Yeah.
Yeah. How is this clip pre-trained? So what is the advantage in this? Like how it is better? So the ImageNet dataset training for most of the vision-based models and other models needs a lot of cost and huge data. So there are human annotators used for annotating the images with text and classifying them into multiple categories. In contrast, Clip learns from text image pairs which are already available from the internet. So it is quite less data expensive and like computationally less expensive. So this has been done using self-supervised learning, contrastive learning methods, and generative modeling methods. So we'll go over the next. Right. So Clip is more flexible model, which achieves a higher, better accuracy model with zero shot performance. So you can train it on few shot examples as well, or zero shot training as well does quite well here in this case. And the Clips model can be used for multiple categories, like including OCR, then object classification, geo localization, and action recognition in videos. So, from segmenting images in the video to OCR and other categories, it can be used. Uh, so we'll go over what is contrastive pre-training. So the main framework which is used in Clip models. So contrastive pre-training uses learning from multiple pixels in the image and resembling making that particular segment in the image, marking it with a text based embedding. So every every image pair here is associated with the text embeddings from the related to it in the citation. So it learns from the image as well as the text and in the matrix form, and in so the image encoder and text encoder both are used in mix to for the training pre-training. Data set classifier used here is so there's one for text and one for image. So there's a text image and text pairs which can be used for training the model. and feeding the image for the zero shot prediction for the model. And it ranks the image query based on the image text provided as in the prompt. And then it displays multiple top k results for that image, and then it can learn from the image. We'll go over the code for this, and we'll understand more in depth how it works. Just yeah. Uh, so this is a tutorial we'll be looking into the multimodal retrieval for Wikipedia dataset for using LlamaIndex. So OpenAI's clip model, there are a lot of clip model variants available. We'll look into VITB32, so which is one of the vision transformer based models for using a clip method. So uh, there is a benchmark for in Hugging Face for the text embeddings, massive text embedding benchmark, and GPT 3.5 will be using for text response synthesizing, which is analyzing the text response and marking it with the image embeddings. So uh, there are majorly 5 steps in this tutorial. So text and image raw files will load from the Wikipedia dataset and the text notations for that. Index will be indexing these embeddings using a vector store like Quadrant client or like some other vector store, and indexing the image embeddings as well and text embeddings both. There is a text model for that as well, and both the text and image embeddings we can store it in multiple different separate collections in Quadrant. And query, as when we do the query, we can retrieve the image and text of respective for that prompt, and it gives a score for that relevancy of the prompt as well.
So one question here: is this the collab notebook that you are showing here? Is this for inferencing, or are you showing the pre-training part here?
No, this is for inferencing. So already this clip model is being pre-trained, so we are loading that, and we are using another data set for just for maybe fine-tuning or getting on a particular separate data set above the pre-training. So
So,
it is already been pre-trained. We are just loading. Yeah.
so this is purely inferencing only. There is no fine tuning involved, right? In this
No,
notebook.
no, no. It is just retrieval of the from the data set. So already pre-training is done on image text pairs by the OpenAI, and we'll be doing the inferencing or like with a particular image text data sets which are available on the internet. So we'll be using the Wikipedia articles data set. So for this example.
Okay, understood.
Yeah, sure. Any other? Let me know if any other query, or I can go ahead. Yeah. Okay. So I'll go ahead. Uh, so we install all the dependencies like LlamaIndex, regex, and other libraries we installed. We import the OpenAI's clip model. We import Torch and other, and vector DB quadrant client. So I'll go over the next steps. From we store the images in directory in our local directory. We have the Wikipedia particular. We can use any examples from the Wikipedia dataset, or we can use any other dataset as well, which has the image text annotations. So here in examples we have a place as well, countries or like city as well, or maybe object and other object. Uh, we have this maybe the main website from which we'll be searching. So this is the Wikipedia API. So if we do a query on this, we'll get the results in the JSON format. So which would be the query about the format, the titles, the content, and yeah, the text. So basically. So we'll be storing that in the format of TXT files, and we'll be writing that. We'll be loading our OpenAI key here, and once all the configuration is done, we'll be storing the image and text embeddings and the indexing in the vector store, which would be the quadrant client. So we'll be importing transformers because Hugging Face has all the vision models for the clip. So we can use any of these models. I'll show you which other models we can use. Yeah. So uh, There's from the LlamaIndex we import service context and directory reader and quadrant client for vector stores. So which would be storing the image and text embeddings in separate collections. So there is a text client for storing the text embeddings in the memory. So we have this path for wiki PDF, and we'll be using any LLM for the text synthesizing part. So we can use OpenAI's any models or any other similar models. For this example, we'll be using OpenAI's model. So GPT-3, 3.5 Turbo, or GPT-4 as well. Yeah. So this is the other embedding model. So this is for embedding generation. So we'll be using Wikipedia, storing that and in the collection of Wikipedia text. So this would store all the text embeddings in the text vector store, and this would be the storage context. So it will be retrieving all the from this vector store. So all the memory from this memory, and this is the text index. So this is the format for vector store index and storing the text documents. And this is the text query engine. So we'll be using this index as for doing the queries. So it is downloading all the modules, tokenizer, and all the files. Uh, we can see how many text documents it has downloaded. So here in this case, it is 4. So we have given 4 here titles, right? So for that, it is 4. So it has downloaded the 4 articles related to
So
this.
maybe you can increase the font size a bit
Yeah,
uh,
sure.
and sort of slow down a little bit.
Yeah, it
Yeah,
is visible. Yeah,
yeah. One question.
Yeah.
Yeah, thanks.
Yeah.
So this GPT 3.5 Turbo, that
Yeah.
can you just go above? Yeah.
Sure.
So is that used to get the text embedding here? What is the role of that GPT 3.5 Turbo here?
Yeah, and so it will be using for the text synthesizing part. So basically, when for the embedding text embedding models, we'll be using this base model
Mhm.
from the Hugging Face, and this would be for analyzing the response. So the text response with the image once we are getting the retrieval results at the end, we'll be using this. So not exactly here, but this would be for using in the retrieval part. So once the embeddings are generated, and we'll be querying using a prompt for getting that retrieval result. So the prompt will be synthesized by this model GPT, and it will result in corresponding text and image embeddings, which will be retrieved from this vector database.
So from where the image embedding is going to come? Is it the one that
So
we are going to give?
yeah. So we'll be having. So there is one part as well
Fine,
for
fine,
the
fine. Yeah,
image.
that is fine. Yeah, if it is going to be covered, that is fine.
Yeah. I'll cover
Sure,
everything.
sure. Go ahead. Thanks.
Any other query? Let me know, or I'll continue. Yeah. Okay. I'll go ahead. Yeah. So we'll load the clip model. So for the image part, we'll be using this model. So we'll be loading the PyTorch clip and NumPy models, like everything, data library and everything. And once we have all this, so we can see the model parameters. So it is around 151 million, and so in resolution and context length and everything. So context length here in this case would be the prompt, or how much relevant, like how much big prompt we can provide, uh, so that the model understands the text, and it is able to capture a relevant image from that. Uh, so we'll be installing the Wikipedia dataset here, and so importing the Wikipedia dataset and the uh, request libraries. So we have these titles. So for each title, we'll be storing the image as in the URL wise for each JPG or PNG format, and we have the path format for it. So we'll be we have these images stored for these all titles currently, and once these images are downloaded from this Wikipedia, so we'll be loading the image, and we can plot the image as well. I'll show you. And so this is what we get. These are the images which we have downloaded for the queries we have made. So I'll go over how we generate the image embeddings, and how we can retrieve the images. Yeah. So for the each image, we'll be doing the pre-processing. We'll be opening the image in a particular size as we want. So, which is the size is defined by the model which we use. So it needs a particular image size. So these are all the models we could use. So we have used this VITB32 model. We could use a larger model or base model or 16 one or other models. So this might give better results as well, or maybe different results. So it is a try and test in this size. So this is a like a moderate level model. So it works good. So and it's a good one for with clip. So yeah. So image. So this is the dictionary. Currently, we have the 14 images. So now separate. We'll develop a separate clip image embedding index under this collection. So we have a separate collection, Wikipedia image collection for this storing these images. Uh, in this, we have all the images loaded with their file path, and in the quadrant vector store. So we can have the text client, and collection name would be the vector Wikipedia image, different collection for images and text. So so from which we have the storage context for image vector store, and there is the image index we define for documents. So these would image documents would have all the images stored, and the storage context would be this Wikipedia image, which collection which it can refer to answer your questions. So function for image query. So we'll go over how we can retrieve. So basically, this is the logic for retrieval, and we'll have few examples below. So uh, so for getting any retrieval, so we'll be using any text. So text would be converted as this would be the prompt. So we'll be converting it to and tokenizing it. So the query embedding would be passed to the clip model, and from the vector store, image vector store, will be matching the embeddings, and there would be a similarity. Here currently we have defined top case. So there are top P or top K. So here relevant only one image we return. So so top K here is one. So and uh, we return the image retrieval results. So we plot the results, and we have a score as well. So how relevant it is. So this is a probability based score from the images, 14 images we have, which matches the most with the query you have. So there is a cosine similarity and other indexes as well we could use. So I'll go over a few examples of retrieval. So suppose we took the example of Kathmandu. So you can go to the Wikipedia API and search for Kathmandu, and the query for which are some of the historical places in class Kathmandu. So it gives the text as well and the image as well with the score. So text is some of the historical places in Kathmandu is included Kathmandu Darbar Square, Patan Darbar Square, and other things. So and this is the image relevant in Kathmandu. So and this is the score from the all the images, 14 images. So I'll go over one more example. So this is a statue in Helsinki in Finland. So it searched for Helsinki, and relevant results appeared. So what it does is it retrieves all the image and text from the Wikipedia article, from which we asked some particular query, and it retrieved this result. So retrieval mechanisms can be also more enhanced, but so for the Tesla example, let's take this example. So which company makes Tesla? So Tesla Incorporated makes Tesla. So Tesla Model S related article is there on Wikipedia source. So we have this URL from which it fetches and gives the result. So yeah,
No,
these
so
were my
let me explain this Mayor. So the input is a textual prompt,
yeah.
right?
We will be giving a text prompt. Yeah.
And the output is a textual response plus an image. Is that right?
Yeah. Yeah. With the score of retrieval, something. Isn't? Yeah.
Okay, score of retrieval. So you and your how is Wikipedia involved here again?
So Wikipedia will be fetching the URL based for the article extraction. We'll be using Wikipedia. So Wikipedia sources from the data, like we will be searching for Tesla Model S. Like the query would be regarding Tesla Model S, and for the say, particular query, we will convert this and tokenize this and pass it to the query. And for that, it will retrieve this source, this URL, and that website web page from that, and the contents including the text and image will be retrieved, and from that matching with the query will be fetching that part.
No, is this doing RAG? Are you
Yeah,
using Wikipedia as a RAG source?
yeah, it will be RAG based mechanism, but using the clip of OpenAI's model and vector, yeah, vectors.
No, basically to find the relevant Wikipedia page, what is the process?
Yeah, so I'll go over again. So how
No,
the
just
we
on a high level. Just on a high level. No need
yeah.
to go through code again.
Sure. So we had a particular data set from so we could have more examples in this. So we have these all Wikipedia titles, and so for each of these titles, we have the URL. So from this Wikipedia titles URL, we'll be going to the wiki search engine, and we'll be searching for these particular titles. And for these, we have a particular associated article for these titles, and from these articles we'll be fetching the images and the text. We'll be storing it in separate collections in the vector
So
store.
basically, you are searching the Wikipedia through a Wikipedia API,
Yeah,
right?
yeah,
And then you are pulling the relevant Wikipedia page for those 4 keywords,
yeah,
and then using that as context in your RAG algorithm, correct?
yes, right.
And the output image is generated by the process of text to image conversion through clip, right?
Yeah.
How is
No,
clip
the
I
image
don't
is not
using?
generated. It is already there on the URL. So we'll be just retrieving that from the result.
What is
So
the role of clip here then? Clip is a
yeah,
text to image or image to text translation mechanism. What
yeah,
is
yeah, yeah.
role of clip?
Clip would be used for encoding these text models and giving a particular image embedding for that model, and then we can use RAG for retrieving the results. So images here would be so image and text association, and generating the particular image embedding for that text query you have would be done by the clip model.
No, but
Is there
image you already have. So why you need to create image embedding? Image is already retrieved from Wikipedia page, right?
No. Like if you don't have that particular Wikipedia source, suppose you are just going over the web as well, you will be having you'll need a particular definite association for your prompt. So your prompt could be very specific as well, or something very generic as well. So retrieving the particular image associated to that text will be using association as a with the clip model. So clip would be in the clip is the vision transformer model here, VIT, this one, and which will be using for getting the image embeddings for each image, and those will be associated with the text embeddings, and we'll be using the vector store for retrieval. Yeah.
Vivek and Mihir, my understanding is that that generation part is not happening here. I don't think the clip
No.
is clip is not
There's no
generating an
generation,
image here.
yeah.
So it
See,
may not be a RAG.
basically, no. Basically, what is happening is he is converting image also into a textual embedding by using clip, right?
No.
Then,
No.
then
No,
image,
there's image to text. There's a like the embedding translation is there, which is in the middle for text and image both. So it would be
correct.
somewhere in the middle, and we'll be associating that for each text embed image pair, and then we'll be retrieving the results for that. Yeah.
So
Shall I-
we want to create a vector database not just with textual embedding, but also with image embeddings. Correct, Mir?
Yeah. Right.
And so then that vector database, vectorized format of both text and images, becomes my context for answering the prompt.
Yeah. Sure.
So
Got it.
just correct me if wrong.
Yeah.
You are giving a prompt here,
Yeah. This is the
textual
query.
prompt, and
Sure.
that prompt will go to that GPT 3.5 you are using.
Yeah.
And that will convert it into textual embedding, correct?
Yeah, so what we have done is already these URLs, like which we have cited. So this would be already stored with the this like URL citation, and the content would be stored in the text embeddings part in the vector store. And we are just with this query, we'll be just retrieving the results. So already the vector embedding part, vector store in the embedding part is already done. So you don't have to do it in the inference part. So it is already done before inferencing. So with the model.
Okay, so there will be two parts. One is text embedding, which will deal with the prompt that you are going to send.
Yeah.
And another one will be the image part. That also you will take it somewhere from Wikipedia URLs or somewhere.
Yeah.
Correct?
So these would be the all the requested content will be having the images stored, and we'll be using
Fine.
these. Yeah. So
Fine.
yes.
So for the text prompt that you are going to give, whatever, you will get a text embedding, and
Yeah.
it will take the most similar image embedding from the store that you are having, and
Yeah.
will return it to us. Am I right?
Yeah. So there is already a text embedding and image embedding in the vector store.
Understood.
We'll be,
You are doing inferencing.
our
I understand.
association there, and we'll be matching it with our query based embedding, and we'll be getting the similarity, and we'll be
Yeah. So
yeah.
so the top similarity one will be shown. Correct?
Yes. Yeah. Correct.
So one question: can we do the reverse here? Like if you are giving the image, can we get the caption back?
Yeah, it is already there are a few models on that as well. Blip and other models are there which do this. So there's research going on that part as well. But with this as well, we can basically instead of you're saying instead of retrieving the image, we'll be retrieving the text caption for that, right?
Yeah, the most similar text caption. For example, if you are giving that that Kathmandu structure, it should give back that this is the some historic place in Kathmandu, like image captioning kind of use case.
Yeah, definitely. So recognizing the image and giving that caption for that, so that is possible using this. Yeah.
With this clip model itself.
Yeah. It is done. Yeah. So there's a use case of clip models for that as well. So all the use cases I'll show you in the presentation as well. I'll give you the part. Yeah. So if the code is done, I'll move on to the presentation. Vivek?
Where is the LlamaIndex is being used over there?
Sure. I'll show you. Yeah. Just give me.
So we are not generating from clip model, right? We are just retrieving.
No. It will be just for association part. So
and we are generating using GPT 3.5.
Sorry.
We are currently generating text using GPT 3.5 but retrieving for clip, right?
So these no. Already the text from the article and the image are already stored in the vector store, and with the GPT 3.5 we'll be just getting the output reformatted or synthesized from the embeddings.
That's generation. That's generation.
Yeah,
and
text
in
generation.
clip model we are not generating. We are not regenerating. It is just fetching.
Let me allow. Can I share my screen here for one moment?
I'll have to unshare.
No, you can stay. I'm sharing my screen. I'm going to show how the RAG block diagram is working here. So
Vivek, I think you should moderate also, because the questions are not being answered. Then you should moderate the question answers also.
Yes, that's what I am doing precisely.
Yeah.
So this RAG process, what is happening here? Just a moment. Somebody is trying to join. So let's understand the RAG process. What's happening here? So based on the first of all, we are creating the vector store or the embeddings, both of text embedding and image embedding. Okay. So the image embedding is retrieved using the clip. The clip is able to create an image embedding, right? Or image to text. So we have created a vector store both from text embedding and image embedding, and which in turn was retrieved from using Wikipedia API. So that's where we got the text and image from for the certain keywords. Now, in step 2, the user asks a prompt. Then this LlamaIndex or LangChain orchestration it does a semantic search. SS means semantic search on the vector store to find the matching chunks in this embedding. So matching chunks are found in the embedding. Along with the prompt, it's sent to GPT for purpose of response generation. And of course, the image was already there based on the image embedding. So, so Mir, correct me if I am wrong, if I got the block diagram right here for your program.
Yeah, Vivek, it is correct.
This is accurate, right?
Yes.
So
yes.
based on Wikipedia API, I retrieved the text and the images. I embedded both of them in the vector store. Then I used, when the prompt came in during inference time, then it did a semantic search on the vector store. It found the matching chunks from the vector store. Use this vector matching chunks are used as context. And along with the prompt, it is sent to GPT API, which is then able to create a contextually sensitive response. And of course, the image was already there from the image embedding.
Yeah, so the text response would be synthesized based on the context and from the text and image embeddings, and as well as the text prompt which we give. So based on that, it will be able to answer. Yeah.
So, folks, any questions on this block diagram of this program?
Just to
Vivek, if the
say,
image is
drag
not
was
there,
applied
then
on,
what will happen?
retriever and
One by one,
generation
please. One by
happened
one.
on. No, so
Yeah,
it
one
means
at
that generation and retriever happened on text, and on image only retriever happened. There is no generation, regeneration.
No, image also is part of the embedding. This is image
But it is not.
embedding.
It is not generating, right? It is not regenerating. It is just.
No, it is not regenerating. It is just like once the image embeddings are there, it will be just retrieved. Yeah.
Okay.
Now, how is this image printed here, Meher?
Like it will be from the embeddings. It will be generating, but it will not be a regeneration as you are talking. Yeah. So.
So image is already there. Image is already there in the
the associated image is already stored in the Wikipedia. From that,
okay.
Yeah, we have the images stored. Yeah.
So I hope this block diagram makes it clear, folks, how the RAG is working here.
Yeah. So one part, Vivek, what you said is like for the text part there is a generation happening, correct?
Correct.
Yeah.
Okay. So that collab notebook, is it a different response that it is giving? For example, if Mihir gave show me a historic place in Kathmandu, so some other response is coming out from the inference. Is that what you are trying to say?
No. This is probabilistic. See, deep learning is probabilistic, right? So it will try to find matching chunks. This MC means matching chunks. Based on this prompt, it will do what we call a semantic textual search on the embedding vector store, and it will try to find, let's say, one or more matching chunks, and along with the prompt, it will send the matching chunks to GPT, and GPT will then use the prompt as well as the matching chunk, which is basically the context, to generate an appropriate, accurate response. It is all probabilistic modeling, so some things could come out wrong as well.
Yeah, so
this is classic RAG. This is nothing but classic RAG. The only addition to classic RAG here is we are additionally using image embedding as well. But otherwise, this is nothing but classic textual RAG algorithm.
What the matching chunk contains? What is inside in this MC?
See, let's say the embedding is massive. Let's say you have 1,000 pages of embedding. Let's assume, right? So they have 1,000 pages of embedding. So it will find the matching pages. So these are the chunks in the embedding. These are where the potential, the prompt answer may be found. So these two pages, it is going to put in the matching chunk. Out of the 1,000 pages here in the vector store, only 2 pages potentially have the answer to this prompt. This is what semantic search accomplishes. So these matching chunks are then used as context. So instead of sending 1,000 pages to GPT, it only has to send 2 shortlisted pages to GPT where the potential answer to this prompt can be found.
So if the image is not there, then in that case, matching chunks, how it will form? Let's say text is there, but
textual embedding is still there. Image is optional, right? Wikipedia page may not have image. but the text
Yeah.
is always there. So embedding is nothing but it is an addition of text plus image embedding. So it is intelligence of both text on that Wikipedia page as well as images on that Wikipedia page, if they
And
are
the
available.
image,
Transformer is
and
for
if the
additional part.
image is
Mainly,
not there, then it will generate that image, and then its corresponding
no,
embeddings to form that chunk.
there's no separate like image generation part here. Only suppose if there is no image on that Wikipedia article, we'll not have an image. We'll just have the text. Yeah. So
Then
we are
the
only using the sources which has the image, relevant images. Yeah.
I mean,
But
Yeah.
if
even if the
classic
image is
RAG
not there in that
process,
particular article, I mean,
nothing new on this. If you know RAG, this is RAG. But only difference is we have added image embedding
no,
also.
uh,
That's all.
no, he said that
Yeah.
no,
Hi.
if the image is not there in the Wikipedia article, it will not it will not come. But it
So
may
this
come,
will
right?
be
If there's
missing.
another
This will
article,
be
if there's
missing.
another article, I mean,
It's
just image
probabilistic.
embedding, right? Yeah, I mean, if there is another article,
It may come,
where
it may not
it
come.
might
It's
be,
Yeah,
probabilistic.
definitely. Like from the other articles, supposedly only one article doesn't have the image, and we are retrieving from that, but other articles have the image. So most closest image from the semantic search will come, but not from that article, since we don't have the image for that. So there would be no generation part here, but we'll be retrieving the most relevant probabilistic result.
also,
For
can I
See,
know
example,
what
RAG
is
has
the chunk
two
size?
steps,
Chunk size
embedding
and
step
embedding
and
size?
inference step. So RAG has always two steps, embedding step and inference step. Embedding, you're creating the vector store, and during inference, you are using the prompt for a semantic search, find matching chunks as context. Along with prompt, matching chunks are sent to GPT API, which generates an appropriate response in a contextual way.
Storage and retrieval.
What is the chunk size, here? I mean, for text and also embedding size for image. Currently,
Yeah. So for the text, it is usually more, but for the image patch size, there's for particular different like vision transformer models, it is different. So I'll show you just if I can share my screen. Yeah. Yeah. Let me know if my screen is visible.
Yeah, share your screen, Mir.
Yeah, I have shared entire screen. Right?
Yeah, we can
Yeah,
see.
yeah. Now it's coming up.
Just a second. Yeah. So this would be for the model, as in the clip model, we'll be having this as the context length for the text, and this would be the image input resolution size. So 2224 by 224 size, and I'll show you if you mean for the embeddings, the context length, and for the embedding
Embedding
size,
size, I think. Size of the
I'll
embedding.
show you. Yeah. So I haven't showed it here, but it is usually there
768,
are
1024.
yeah, 1024 is usually the one, but it can be more as well for certain models. So we have different models as well in the vision transformer. I have showed other options as well you could use. So
If you can show us the embedding that you are using, which specific embedding?
this is the model for text embedding. So BG,
Okay.
you can look up for the size.
We can check in Hugging Face. Yeah.
Okay. Uh,
you
any
said
other?
clip, right?
Yeah.
Is it? So it's a different one. Just wanted to know.
No. This is for text embeddings, and clip is for image embeddings.
Okay.
And clip does the association between the text and the image, but you have for the generating the text embeddings, you have other model. You can use OpenAI's text DaVinci or for the text generation, but embedding generation, there are embedding based models like BERT based or transformer models or any
ADA embedding 002.
What is the chunk size you have used for this case?
Yeah. So there are different context length basically. Yeah. So here the context length is like 77 tokens length, and these are all the parameters. So and
Context length. This is for image. Yeah. Okay.
yeah, no, this would be for the like this would be even for the image and the text associated. So text could be more as well. Text text will have the based on the text embeddings model you have used for the association. So and
In the
yeah,
quadrant, right? You're using quadrant. The quadrant,
yeah,
what is the embedding
Quadrant.
size?
yeah.
Quadrant.
So this is the you'll for the quadrant you'll be using this as the text synthesis and just a second. My screen is lagging a little bit. Just give me one minute. Yeah. Okay. So sorry, I can you repeat your question?
I mean, for the entire
Yeah.
Wikipedia article, you'll be chunking your article, right?
Yeah.
When you put quadrant in the quadrant. So, what chunk size you've used, and what is the embedding size of this model?
Yeah. So embedding size. Uh, uh,
The
it is not.
combined token.
No. Yeah. But it is not defined here. Like you have based on the model, it is there. So you can see it for the each model. Uh, I'll show you the OpenAI's clips documentation as well. You can have a look. I'll share the resources so you can maybe check on that end. Uh, yeah. So I'll show you for answering your question. I'll show you the OpenAI's paper as well. Is my screen visible? Complete?
This chunk size, na, for text, you have to choose when you put the quadrant, not open. I mean, the embedding size
No,
is
no,
already
no.
defined.
Yeah, embedding size is based on the model you use, and for the chunk size, you can basically you can choose it from the based on the context. So there are parameters for that in the quadrant. So you can play around with it. There's different sizes you can use. So yeah. I haven't defined any particular chunk size here. It is maybe for some of these use cases, it is taken in default, the standard chunk size. So it could be around. I have to check. I'll get back to you on that. Yeah.
If you don't define, and if you put a whole Wikipedia article, it'll cut down, those tokens. Only
No, no,
half
no, no.
information is.
It will be chunking in the format itself, but it is not defined in here. So I have to yeah, like I'll get back to you. It is maybe in the quadrant side documentation. I have to check. Yeah.
And image part, image,
Yeah. Yeah, I'll
image.
go to the image part. Just yeah, I'll go down. Just image embedding. I'll go to the yeah. Just yeah. So this is the image collection, and from this we have the context, storage context here, and everything. And so this is the dictionary format for the images. And when we are doing the retrieval, query embeddings, yeah. So yeah, so image embeddings, you have to. I'll get back to you on that part. Yeah.
Okay.
Okay. Let me know if any other questions. I'll move on. Vivek, can I go ahead?
Yeah. Go for it.
Okay. Sure. Yeah. So we have seen the code demo, and I'll go ahead. Just a second. My presentation. Okay. So if you want to have a more look at the clip model, so there is an OpenAI's GitHub clip article is as well there, and repositories as well there, and this is the model for the clip. So transferable visual models from the natural language supervision. So this has all the benchmarks, how the contrastive pre-training is done, and uh, the benchmark. So with the zero shot pre-training and with other bag of words, contrastive learning and other methods, how much accuracy they have got in the pre-training part. Uh, So these are losses, embeddings, and cosine similarities for the retrieval part in the clip, and how each modality is taken care of. It is provided here. Uh, so they have tested with few shot and zero shot transfer learning and methods. I'll go over the key points in the presentation. Just as, yeah, let me know if my screen is visible. I'll make it in presentation. Yeah. So these are few of the results from the multimodal retrieval. These were in the paper, so I'll go over these results. Is my screen? Can you see the presentation, or is it loading? Can anybody confirm?
It's still loading.
Okay. Okay. There's maybe issues in the sharing part. I'll reshare. Yeah. Can anybody confirm now if it is visible? I'll make it in the full view. Yeah, if there's an issue in this presentation sharing mode, I'll go over it quickly.
Yeah, you see a black screen.
Yeah, yeah. Vivek, if now it is visible, if I don't go into
No.
presentation mode,
Yeah, now
still
Maybe
you're not. Yeah,
it's
I'll
visible.
keep
You can just do. Yeah, you can do
Yeah,
function F11 to maximize browser window itself.
okay, okay, yeah.
Function F11 will maximize the browser window.
Or just a second, Vivek. I'll just zoom in so you can see it.
Hmm.
Yeah.
Better.
Yeah. So these were the few of the outputs. So if we search for BTS, which is a Korean band, so we get the similarity results for the image retrieved and the node ID from the image which for the retrieval. So we can do it for Tesla, for any other example. So there's different image text data sets available which support this format. So currently the newer models which can do this, our GPT-4V vision model has also the capability for this, and there are other vision models introduced by Microsoft Research and other this. So we'll go over what are the advantages and disadvantages of each of these models. Yeah, so limitations of using clips. So we'll be looking into why this clip is maybe we can go over different models as well. So what are the other options as well? So clip is good at identifying generic objects, but specific if there is an abstract topic or something more number of objects are there, it is hard for clip to understand. So zero shot clip only performs slightly better than random guessing, so which is more than just 50 to 60%. So if we do a few shot training or on different data set we do the zero shot clip, so it achieves 88% accuracy, which is lower than the human accuracy on this data set. So by human accuracy, I mean a human annotates or does the classification on a pet. There's an Oxford pet data set. So other data sets as well. There's human classification score, and this is the model's classification score. So the other models which are available for this task are GPT-4V, which is a vision model, Lambda and Gemini, which are the Google's models. So these are also one of the models for vision tasks. And these are some of the resources. So this is the CLIPS website and a model article. Yeah, I'm open to questions. Yeah. Any other questions?
Okay, sounds good. Any questions, audience?
Nope, it was good. Thanks, Mihir. Thanks, Vivek.
Thank you.
Yeah, that multimodal image plus text RAG was interesting.
Yeah.
So that creates a lot of possibilities of innovation. Any final questions, audience?
If anybody wants the code as well or as the presentation slides, I can share it with you later on. You can just ping me on the Cellstat, or I'll share it with Vivek, and Vivek can share it with anybody who needs. Yeah.
Yeah, all webinars are recorded. We do provide them to our members in the Cellstrat AI Lab community. So if you're not a member yet, you can join our community. And the way to join our community would be you can reach out to me. My name is Vivek. I am the co-founder for Cellstrat. And I'm sharing my number here, which you can WhatsApp me, and I can tell you the process to join our community. So the recordings are put on our YouTube channel, but they reach on our YouTube channel a little later. First, they are shared with as a Google Drive link to our community members right away. So nice session, Meher. Good, interesting discussion on multimodal LLM. I think in our new GenAI product, which we announced yesterday, we should add this kind of capability, a multimodal, textual modeling or language generation. So let's work on that, Meher, and let's work on the next webinar as well.
Yeah.
Okay, so if there are no comments, audience, thanks a lot, Meher. Good presentation, good hard work you did, and it was a nice demo as well of a multimodal LLM.
Yeah.
So thank you all for joining. Wishing you all a very, very happy new year.